Mid-February 1943, Sidi Bou Zid, Tunisia. In the swirling desert sand, officers from Germany's elite Heavy Panzer Battalion 501 gathered around their newest prize, notebooks already in hand. It was a captured M4A1 Sherman tank, its American star still visible beneath a hastily painted German cross. The tank, bearing the name War Daddy 2 on its hull, had been captured intact and fully operational during the recent battle. But this was far more than a simple battlefield trophy. This single tank was already a profound mystery. A German reconnaissance unit had just driven it, under its own power, 350 kilometers across the brutal North African terrain to the port of Sfax. For these German tankers, accustomed to their own high-performance but fragile machines, this simple, uninterrupted journey was a quiet, deeply unsettling revelation. This captured prize was about to trigger a crisis of confidence that would echo through German engineering for the rest of the war. That 350-kilometer journey across the desert to the port of Sfax took 4.5 days, and it became the real story. For the German tank crews accompanying it, every kilometer was a quiet, terrifying revelation. They were accustomed to their own Panzer, complex, high performance, and mechanically fragile, requiring frequent stops for maintenance, even on short road movements. Yet, they watched this captured American vehicle with growing unease as it simply worked. The engine never overheated. The transmission never failed. The final drives maintained consistent performance. Every kilometer it drove without complaint through terrain and conditions that would have disabled their own equipment contradicted everything German assumptions had told them about American industrial capability. This wasn't a superior weapon because of its gun or its armor. It was superior because it simply refused to break. To understand this shock, we must first understand the German problem, their entire design philosophy. The German worldview was built on what they saw as theoretical perfection. Engineers designed tanks like the Panther and Tiger as complex, over-engineered marvels that looked invincible on paper. They prioritized the most impressive specifications, the thickest possible frontal armor, and the most powerful high-velocity guns. But this relentless pursuit of performance came at a fatal cost. Catastrophically overtaxed powertrains, fiendishly complex maintenance procedures, and disastrous unreliability. German tanks were not designed for common soldiers. They were specialist machines that required highly trained specialist crews and constant expert attention just to keep them running. This was their ordinary world. A doctrine of superior, complex engineering that was about to be shattered by something it couldn't even comprehend: simple automotive excellence. At the port of Sfax, War Daddy 2 was loaded onto a cargo ship bound for Germany. The Army Weapons Office had issued explicit orders. This was not just a trophy. This tank must reach the testing facility at Kummersdorf intact and fully operational. In the spring of 1943, it rolled off a transport rail car at the Kummersdorf Proving Ground, located just 25 kilometers south of Berlin. The alien artifact was now deep inside the Lad. It was assigned a new German designation, Beutenpanzer, captured tank, V2S, FKZ 259, and given the license plate WH058941. Test engineers immediately swarmed the vehicle, stenciling precise armor thickness measurements and angles across every single surface, marking it up for a comprehensive evaluation program. The Sherman was about to undergo the most exhaustive automotive examination German engineering could possibly devise. The initial inspection began with the powertrain specialists, and it was here the first shockwave hit. When they opened the transmission, the German engineers found something that defied their industrial logic. Their own tanks, like the Panther and Tiger, employed straight-cut gears. These required incredibly precise tolerances, demanding highly skilled labor and frequent, delicate maintenance. The Sherman, by contrast, used herringbone cut gears. This design, which had been standard in American automotive manufacturing since the 1930s, was an engineering marvel of practicality. It distributed stress across multiple teeth at once, providing exceptional durability while requiring far less manufacturing precision. The German engineers stared at a component they themselves had considered but ultimately dismissed as too difficult to mass produce given their industrial capabilities. Yet, here it was. The Americans weren't just making them, they were manufacturing them by the thousands. This wasn't just a different design, it was a fundamentally superior industrial philosophy, and it was the first blow in what would become a deep crisis of confidence. The revelations continued when the driving trials began. The German test engineers were stunned to find the Sherman's transmission featured 5 forward speeds plus 1 reverse, with synchronization in gears 2 through 5. This seemingly simple feature had profound implications. It completely eliminated the need for double clutching during normal operations. This 30-ton war machine was, as the stunned testers noted, nearly as easy to drive as civilian automobiles, requiring only minimal specialized training for its drivers. This stood in stark, glaring contrast to their own designs. German tankers had to spend considerable time in training, learning complex double-clutching techniques and careful throttle management just to avoid catastrophically damaging their own fragile, unsynchronized transmissions. The core philosophical difference was laid bare. German designs assumed a highly trained specialist would be at the controls, while the Sherman's design accepted that ordinary soldiers with basic automotive knowledge would be operating these machines in combat. The third trial in this systematic dismantling of German assumptions was the power plant. War Daddy II was equipped with the Continental R975 radial engine, and it immediately impressed the test engineers. It demonstrated a remarkable tolerance for varied operating conditions, maintaining consistent performance across temperature ranges that would have caused their own high-strung German engines to overheat or lose power. Its cooling system, though simple in design, was highly effective. But the most galling revelation was the air filtration system. It flawlessly handled desert sand, resisting the frequent clogging that plagued German tanks in North Africa and ground their own advances to a halt. From the impossible gears to the civilian transmission, and now to the engine that simply endured, every single component reflected a design philosophy that the Germans had tragically ignored, one that prized practical functionality over theoretical optimization. This brings us to the narrative's ordeal, the moment of public, high-stakes humiliation. On June 6, 1943, Reich's Minister for Armaments, Albert Speer, arrived at the Hillersleben artillery range. He was there to preside over a major armament conference, attended by senior Wehrmacht officers and Germany's top industrial leaders. Speer, who was personally accountable to Hitler for results, needed to understand how German designs truly measured up against this new enemy equipment. The demonstration program included hill-climbing trials. The captured Sherman, War Daddy II, sat alongside Germany's newest and most advanced designs, a brand new Panther tank fresh from production, and the massive 65-ton Ferdinand tank destroyer. This was the central set piece. The solution versus the problem. The Sherman went first. It climbed the test slope smoothly, its synchronized manual transmission shifting without hesitation. Its engine maintained consistent power, and the driver handled it with an ease that was now becoming a hallmark. Then, the Panther followed. Its more powerful 700-horsepower Maybach engine allowed it to match the Sherman's performance, But as the assembled officers noted, it did so only barely and with considerably more difficulty. The superior German design was already struggling to keep up with the crude American one.
Then came the Ferdinand. This was the moment of climax. This 65-ton monster, technically sophisticated with its advanced electric transmission system, represented the very pinnacle of German theoretical engineering. It began its ascent, and then, partway up the incline, it stalled. In front of Albert Speer, in front of dozens of senior officers and industrial leaders, the Ferdinand sat dead on the slope. Speer watched as recovery crews struggled to restart the vehicle, an embarrassing failure occurring before the Reich's entire armament leadership. In that single, stalled-out moment, the simple American tank, built not for theoretical perfection but for practical, automotive excellence, had just publicly and decisively humiliated Germany's most complex wonder weapon. The problem had just failed, spectacularly, right in front of the solution. The results were undeniable. In his memoirs, years later, Albert Speer would write about the Sherman's very favorable cross-country mobility, noting reports that it climbed mountains German tank experts considered inaccessible to tanks. The public assessment, carefully managed, appeared in the Das Reich newspaper on June 27, 1943. The article called the Sherman a praiseworthy product of the North American steel industry and even acknowledged its innovative gyro-stabilized gun. But these public statements, carefully worded for propaganda purposes to avoid appearing defeatist, concealed the private alarms spreading through German engineering departments. The carefully couched praise masked a much deeper, more frightening realization. American tanks weren't just adequate, they were fundamentally better engineered for sustained field operations. By late 1943, Kummersdorf had accumulated enough data to produce its comprehensive internal reports, which circulated through Wehrmacht technical branches. This was the reward, the hard-won elixir of knowledge. And the picture it painted was sobering. The documents, intended for senior officers and armaments ministry officials, stated an uncomfortable truth. The Sherman demonstrated an automotive engineering maturity that Germany fundamentally lacked. The engineers were forced to confront a painful paradox. American mass production techniques, which German precision manufacturing would have considered sloppy, resulted in more reliable vehicles that functioned better under actual field conditions. The solution was now fully revealed. The Sherman's design, built on interchangeable parts, meant that field repairs could be accomplished with basic tools and minimal specialized training. German vehicles, by stark contrast, required factory-level precision and specialized equipment for many repairs. The truth was undeniable. The American philosophy of prioritizing keeping vehicles operational decisively beat Germany's pursuit of theoretical performance maximums. The internal German engineering assessments now pointed to the real source of the Sherman's power, the true solution that Germany couldn't match: decades of civilian automotive industry experience. This was the systemic Coca-Cola reveal. Before the war, the United States had widespread automobile ownership. Cars were commonplace among ordinary citizens across all economic classes. In Germany, cars remained luxury items for the wealthy and party elite. This vast difference in industrial maturity was everything. While America had Ford, General Motors, and Chrysler mastering mass production for a nation of drivers, Germany's much-hyped Volkswagen program, promised to German workers since 1934, had delivered fewer than 1,000 civilian vehicles by 1939. This civilian experience translated directly into design philosophy. Americans built tanks that mechanics with civilian automotive training could maintain, using skills they already possessed. The Germans built tanks that required specialist training and constant expert attention. One nation built tanks like cars, the other built them like prototypes. This is where the Kummersdorf testing data was chillingly confirmed by field reports accumulating from the Eastern and Italian fronts. The Panther, Germany's great hope, was proving to be a mechanical disaster under the exact combat conditions the Sherman was built to endure. Its final drive system, inherited from the Tiger, was prone to catastrophic failure under the stress of the 45-ton vehicle. German mechanics reported final drive breakdowns that forced crews to abandon their tanks after movements of less than 100 kilometers. This fragility led to field manuals containing a pathetic list of operational restrictions. a do-not list for a frontline battle tank. Drivers received explicit instructions not to change gears frequently, as excessive shifting damaged the transmission. Third gear, in particular, broke so often that field manuals warned against its use except when absolutely necessary. Most absurdly, crews were forbidden from turning the Panther while backing up, as this simple maneuver would destroy the transmission. This list of failures creates a sense of awe in reverse. It stands in perfect, almost darkly humorous contrast to the Sherman, which testers were already comparing to a simple civilian automobile. The numbers coming from the Kummersdorf tests and the Eastern Front field reports were unambiguous. They told an irrefutable story of comparative reliability. First, operational readiness. Through most of 1943, Panther operational readiness averaged below 40%. During the critical Operation Citadel at Kursk, that number plummeted to a catastrophic 16%, with mechanical failures eliminating more tanks than enemy action. By comparison, Shermans consistently maintained substantially higher availability in every theater. Second, engine lifespan. In March 1944, German reports celebrated an improvement in Panther engines, which had finally achieved a service life of 700 to 1,000 kilometers. This success merely brought their engine to roughly one-third of the Sherman's capability. The Sherman diesel variant, tested at Kummersdorf, exceeded 3,000 kilometers. Finally, the final drives. Field reports documented that Panther final drives routinely failed, sometimes within just 100 to 200 kilometers of operation. The Sherman's final drives, built with those impossible herringbone gears, rarely failed. These weren't opinions, they were capstone facts that proved the entire thesis. But perhaps the final, most telling proof, the ultimate validation, came not from the Kummersdorf engineers, but from the German combat crews themselves. As their own tank infantry degraded, field units grew desperate for any reliable vehicle and eagerly employed any captured American tanks they could obtain intact. This desperation revealed a stunning truth. Unlike captured Soviet T-34 tanks, which the Germans had to modify extensively before they could be used, the Shermans entered German service without a single change. The reason was as simple as it was damning. They didn't require modification because they worked correctly as designed. The ultimate example of this battlefield preference came in January 1945. The 10th SS Panzer Division captured 12 M4A1 Shermans at Hellesheim and immediately formed them into the 13th Company of their Panzer Regiment, using them as mobile reserves for the rest of the war. German commanders in the field recognized what Kummersdorf had proven. A Sherman that reliably arrived at the battlefield was infinitely more valuable than a Panther with superior firepower broken down 20 kilometers behind the lines. As the war progressed, the German problem system didn't just crack, it began to completely disintegrate under the combined weight of its own complexity and Allied industrial might. Allied strategic bombing campaigns targeted the key bottlenecks in the Panther and Tiger production chain with devastating effectiveness. The most catastrophic blow came on the night of April 27, 1944. A Royal Air Force raid of 322 aircraft struck the Maybach engine plant in Friedrichshafen, in what archives describe as the most damaging raid on German tank production of the entire war. The attack also destroyed the adjacent ZF gearbox factory. In a single night, German production of both tank engines and transmissions halted completely, and it would not resume for 6 long months. When production finally staggered back to life in November 1944, quality control had evaporated. German factories were now increasingly staffed by slave labor, as German workers were conscripted for military service. This introduced a new internal enemy: deliberate sabotage. Workers jammed cigarette filters in oil passages, installed gaskets incorrectly, and assembled components without their proper clearances. This provides the final, stark moral contrast. While Germany's war machine, built on suffering, literally self-destructed from within, Sherman production continued unmolested. It was safely located in American factories, staffed not by slaves, but by motivated workers earning good wages under decent conditions. The problem system wasn't just inefficient, it was morally bankrupt. and it was collapsing under the weight of its own brutality. The final official admission of German automotive failure came on January 23, 1945. At a meeting of the Panzer Commission, a report was produced that documented the catastrophic state of the armored forces, not from enemy action, but from their own mechanical failures. The findings were devastating. The report detailed 500 defective final drives in the Panzer IV, 370 in the Panther, and roughly 100 in the Tiger. These weren't just battlefield losses, these were tanks crippled by their own design. General Wolfgang Thomel, Chief of Staff of the Inspector General of Panzer Troops, explained the operational impact in stark, unambiguous terms. In such circumstances, orderly utilization of tanks was simply impossible. He went on to admit the catastrophic psychological cost, stating that the troops had lost confidence in their vehicles. They had begun to abandon whole vehicles just because of final drive problems, terrified they would be stranded and captured. This was the moment the problem was officially declared dead, an authoritative resolution where the Germans themselves admitted their design philosophy had failed. This is the return with the elixir, the perfect, satisfying conclusion to the hero's journey. The hero in this story, German engineering, survived the war, and it returned, carrying the hard-won elixir of knowledge from Kummersdorf. When the new Federal Republic of West Germany began developing the Leopard 1 main battle tank in the 1950s, the designers consciously rejected the old philosophy. They deliberately emphasized reliability and maintainability over the pure, theoretical performance specifications that had doomed the Panther and Tiger. They studied American automotive engineering principles and applied them directly to military vehicle development. The resulting Leopard 1 was built on the very design philosophies that had made the Sherman successful: a robust powertrain with substantial design margins, easy maintenance requiring minimal specialized tools, and standardized components that enabled rapid field repairs and future growth. The Leopard 1 became one of the most successful and dependable tank designs of the Cold War era, serving with numerous armies for decades. It was the ultimate validation. The enemy had learned the lesson, rebuilt their world with that knowledge, and in doing so, offered the final, definitive proof that the Sherman's design philosophy had been right all along. The story of War Daddy 2, that single tank captured in the desert, ultimately proves a fundamental and decisive truth of modern warfare. The weapon that functions when needed will always beat the weapon that is merely theoretically superior if it can't reach the battlefield. In a global, mechanized conflict, victory is not just determined by specifications, but by logistics, maintenance capability, and sustained operational availability. The German engineers at Kummersdorf, in their meticulous, exhaustive testing, understood this truth by mid-1943. They saw the evidence with their own eyes. But understanding a problem and having the capacity to solve it are two fundamentally different challenges. Germany's industrial system, which prioritized theoretical perfection, lacked the maturity and flexibility to retool its production around reliability while fighting a losing war. America, by contrast, had already built that reliability into its civilian automotive sector over decades of commercial competition. It simply extended those mature principles to military production with devastating success. The Sherman's relentless reliability was the final, devastating proof that Germany had already lost the industrial war long before the fighting ever stopped.